Alright, so let me just recap again. So for today's lesson, we'll be going your 3D modeling basics, and then the workflow kind of tips on how you can keep up with your progress, as well as the tutorial mainly targeting how do you model your isometric room from your 2D plan, and then taking the side model from CAD Mapper and further modeling it. Then next week we'll be doing the command make 2D, so we'll be converting your 3D models into a 2D drawing, and that's done through the Rhino command make 2D. You can see, and then I'll be also showing you how you can export it via the two kinds of views. The first one is the isometric, and then the second one will be your axonometric. And all the same rules of your line weights and your line types from exercise 1 will apply here as well. And we definitely need to spend some time just going through the GIF animation basics or recapping, but I think most of you already have it done. So in this case, there's a few ways of doing your GIF. Either it's moving the camera in Rhino, or you export frame by frame again and doing the stitching in Photoshop. So there's a bunch of ways you can do it. Then after that, it will be recess week, and we see if we need another tutorial or not. So for today's lesson, covering some past year outputs and workflow tips, and then afterwards we'll be going through the basics of all the 3D objects in Rhino. So if you all don't know about it yet, it's your surfaces, your poly surfaces, meshes, and sub-D as well. For your main architectural features, you'll be using the simplest extrude curve and stuff like this, creation of all these surfaces and B-reps. Then followed by your context, which is your side model. You'll also be doing the same kind of like just extruding your curves. And then in order to create the openings and your windows, you'll be doing the Boolean operations. And last but not least, if you want to have any freeform objects, any curvy objects, that's when you need to use lofting, and you need to manipulate the control points of a NURBS curve. So you're familiar with the interpolate curve and NURBS curve, right? Those will generate your curved forms. So we'll be showing you how to manipulate these points in 3D. Then this I'll go through next week. So for your workflow, right, I think if you look at the example on the left, it's best for you to model as much as possible that in your capability in Rhino. So as much as you can in your 3D, whether it's the soft toy, let's say for your soft toys, your computer monitors, your curtains, blankets, stuff like this. If you can model it in Rhino, try to do it. For the more complex objects, in this case, as you can see for Yiwei, one of your seniors, right? He said that he traced it after he made 2D. So he just took a photo of himself from a kind of isometric view, and he traced it because it's pretty hard to model a human in Rhino. So there are portions where you need to find that maybe it's you kind of give up the modeling process and you move on to the drawing process instead. So in this case, like I said, the human, maybe some complex soft toys or plants, stuff like that, you may want to trace them out instead of modeling them. And then the next one will be deciding on your representation. So as you can see, for all the ISO drawings of the room, right, there's always two faces of the wall that are missing. So these two faces that are missing is meant for you to review the space inside. That's why we need to take away the two walls, I mean. So in this case, there are a bunch of ways that you can remove the room. One is by exploding the drawing. So I think if you all are familiar with this, is the exploded ISO. You are taking all the things that you modeled, but in order to showcase the inside of the room, you're exploding out the faces that are sort of like hiding the space of the room. So you're exploding them out by a certain distance, and you are still showing them in continuous lines. The other method would be to not explode them, but instead you'll be representing the two faces purely with hidden lines and dotted dash lines. So in this case, the hierarchy of seeing the space is still with the continuous lines, but you are not kind of removing any of the extra detail that you had modeled. So you are still keeping them through the dash lines over here. The last method would be through your partial hiding of certain surfaces. So let's say if you want to hide the wall, but you still want to showcase the cupboard, it's possible with this kind of representation. It's a bit kind of iffy because you're hiding some details in your room, and this is kind of not recommended in this case. But through the few tutorials, then you start to see what's the style that's suited for you lah. So I wouldn't say it's not possible, but it's something that you should be cautioned about. Then the last one would be focusing on clarity of visualization. So once you have your Make 2D, you have all the lines ready in Rhino, right? That's when you need to start to go on to your post-production, which is in your Photoshop. So you need to focus on clarity and depth. The clarity is done through your line weights and your line types. For your depth, it's best to have some kind of shadows, so you should export the shadows of your Rhino model as well, and then overlay it with your drawing. So in this case, the shadows help to show the depth and like the time of day of the room. So these are the bunch of layers that we need to have in your drawing. So what's a Make 2D command? Basically, it takes the camera view of whatever you see in Rhino, right? So in this case, you set the camera view in Rhino as isometric. You type in Make 2D and you'll generate all the lines from that camera view. So it will generate all the lines on the 2D XY plane, and this will result in a 2D drawing that you can finally kind of start drawing same as your floor plan. It's the same workflow. Alright, so this will be the commands that I'll be covering today for Rhino. Before we start the exercise, does anyone want a break first? If not, we go on with the... Okay, then let's go on with the exercise. Okay, do you all have this open? I think the first of all, let's just try to implement some shortcuts in Rhino now. So we don't need to type all the commands in full, we can use the shortcuts. So first of all, let's just go to our aliases and add a bunch of shortcuts. I recommend you to add BD as Boolean difference, BS as Boolean split, BU as Boolean union. So go to your options, go to your aliases and add all this. Start with BD. BS, BU, your curve boolean if you haven't added. For the command macro, it has to be the exact spelling as what is shown here, so make sure you copy word for word. The next would be extrude curve. So I use EC for extrude curve, ES for extrude surface, F for fillet, FE for fillet edge, O for offset, OS for offset surface. So you can just, to create a new alias, you just need to keep pressing new and type in the command plus the alias. And PS for planar surface, R for rotate, R3 for rotate 3D, oh, okay, true.
Because if you're giving them so many, then might as well.
Okay. Okay. So Isaac has recommended me to just export the entire thing. So you can go to the OneDrive again. And I have this text file called alias, right? So you download it and you can import it over here. So this will help everyone to have the same commands as what I have. So go to the OneDrive, download alias, and import it. Alright. Okay, so I will go through first what are the different 3D objects in Rhino. The first one would be how Rhino natively models all 3D objects, which is through a NURB system. So whether it's your cube, your wall, your surfaces, your poly surfaces, it is all through a Rhino kind of format. And Rhino is able to generate a totally smooth curvature because of their NURBS modeling. However, let's say if you download files from the internet, you download kinds of models that are not made from Rhino, they are made from Autodesk Maya or Blender. They will all come in meshes instead. So what meshes are is they are approximations of the Rhino surfaces. So they are not entirely smooth. They are always made up of surfaces and faces and vertexes, like you see here. So it kind of takes the original sphere you have and generates a lot of faces. The further the subdivision is, the kind of closer the approximation of the mesh is to the original surface. And the less faces it has, it means that it's lower poly count, but then the file size is lower. So these are what meshes are in Rhino. We won't be really using them unless you import them in from internet lah. And the last one will be a sub-D. So what a sub-D does is it kind of mimics a mesh kind of modeling method. However, it's something new in Rhino where although the way you manipulate the control points and faces are done through a kind of polygon system, when you press tab, it changes the visualization from something very polygonal to something very smooth. So it makes a best fit curve that goes through this polygon. So when I press tab, especially for the mouse, if you see, right, when I press tab, it changes the polygon that you saw previously into a smooth surface. So this is a third format in Rhino that you can use to model out organic objects. However, for the purpose of this 2 weeks, we won't really be going to sub-D, but it's something good to know. Now for the first command, let's go through how do you kind of orient stuff in 3D. So as you all know, you'll be mainly drawing your whatever things in a 2D plane first, and then you'll be subsequently orienting them in a 3D space. So the way you can do this is through the command called orient 3-point. So let's say I have this 2D drawing of a painting, right, and I want to kind of paste this on this wall. The way I do it is through orient 3-point. So let's grab the entire drawing over here, and then you'll type in orient 3-point. And then the first thing you need to do is you need to orient the initial plane to the final plane. So for the initial plane, you need to grab the origin point, the x-axis and the y-axis. So I'll grab the origin point first, grab the x-axis, followed by the y-axis, and I'll translate it to the new origin point, which is on this wall's bottom corner. Then go along the edge to denote the x-axis, and denote this edge to the vertical edge for the y-axis. So this is how I translate a 2D drawing that's on an XY plane to a face that you want. So let's say you have one of the walls modeled. This is how you can bring something from the floor to the wall. Is everyone so far so good with this command? The second one would be using your C-plane. So it's the same thing as your exercise 1. Exercise 1, we make use of C-planes to, let's say, draw on a different angle and stuff like that. Same for exercise 2. So let's say you got a wall here and you want to draw on the wall. The best way to do it is to make use of a C-plane. So we'll draw a C-plane on the wall first. And to do that, we'll go to C-plane. Go to set C-plane by 3 points. And we will set the origin X and Y axis on this wall. So let's snap to the bottom corner here. Go along the X axis. Then go along the Y axis. And you can see a C-plane has now been constructed on this wall. So do you all manage to get this C-plane using the set C-plane by 3 points? So now, how do you draw stuff on the wall? Let's go to a NURBS curve first. Let's go to control point curve. And we'll turn on project because we want to be drawing a projected curve on the new C-plane. So let's turn this on at the bottom. And now you can see that when I draw whatsoever, it's always snapped to that C-plane. So this will ensure that the curve is always planar to whatever C-plane they are drawing, as you can see. Okay, just spend about 2 minutes just doing the same command again and again, so maybe you can familiarize yourself with it. You can keep drawing whatsoever curves that you want and make sure that it's always snapped to the C-plane. And if you want to revert back to the previous world plane, you can just press set C-plane world top, or you can go to undo C-plane change, which I'll do right now. So always remember to turn off the project when you don't need it. Okay? So for the next part of the section over here, I'll be explaining what a closed polysurface versus an open polysurface is. So as you can see, an open polysurface means that the solid that you see does not enclose an interior volume. The top and the bottom, as you can see, they are kind of not capped, they are kept hollow. So this means that the entire surface is open. So this kind of will translate to, let's say if you model out your walls, right, and if you see that you can see the in-between of your walls, that's because the polysurface is not closed, it's open. So the way we can close the open polysurface is by clicking it and typing cap. This will help to fill up the top and the bottom with an extra surface. And you can see that now when you click on the surface, it's now identified as a closed solid polysurface. Previously, it's an open extrusion. So for most of our solids, and let's say you're going to model out a cupboard or a wall, your objects, make sure all of them are always closed polysurface. So you make this check by looking at the right hand side that says closed. You don't want it open. So the same thing goes for an closed polysurface. As you can see now, all the faces are enclosing an interior volume. That's why it's a closed extrusion. Now let's say we want to take out one face. We can type in the command extract surface, and your copy will set it to equals no. So what extract surface does is it removes one of the faces from the polysurface. So I'll click on this face here. Then when I press enter and I delete it, you can see that one face has been removed from the closed polysurface, and this has become an open polysurface now. Okay. So on the other hand, do you guys think that this is an open or closed polysurface? I mean, without looking at the words. It's hollow in the middle, but do you think it's an open or closed polysurface? The thing about this is a closed polysurface because it is still enclosing an interior volume. You can see that there's an outer curve and there's an inner curve. There's an there's kind of like an exterior envelope, and there's an interior envelope as well. And it's kind of bridged with a polysurface on the top and the bottom. So, and it means that this space in between the interior and the outer curve is closed. That's why this is shown as a closed extrusion instead. It's not an open polysurface. So this will be kind of similar to the walls that you create in your room. There will be an exterior wall. There's an interior wall as well, and it will be capped at the bottom and the top. That's why it's shown as a closed polysurface. Now, remember your commands trim and split previously? If we use these commands trim and split, they will make your closed polysurface an open one. So we cannot really use these commands in your 3D space. So to demonstrate, right, I've got a curve here and I want to split this closed polysurface by that curve. So what I'll do first is I'll extrude the curve by a certain distance that totally overlaps the cube. And then when I click on this and I split or trim it, let's say if I trim it this way, you can see that the eventual result is an open polysurface. So this means that the polysurface is no longer a nice enclosed one. So we cannot really use these commands for 3D objects. Same for split. Let's say if I extrude this curve and I split this cube, we get two resulting volumes, right? But both resulting volumes are open polysurfaces. So we can see that there's a hole here and there's a hole here as well. And in this case, you may notice that if I type in cap, it will not work because cap only works for closed planar loops and edges. So previously it worked because this entire face is planar, but this entire face, it has a curvature to it, so this will not cap it properly. So how do you close this in this case? What we do is we need to patch up, we need to create this surface first and then join both surfaces together. So to patch up this surface, right, all we need to do is to extrude this edge all the way to the ground. So I'll show that over here. So let's say I have this volume, right? I can just type in extrude curve. I click on the top edge, press enter, and I'll drag it to the bottom. So this will help to create a surface that spans from the top to the bottom with this profile, this curve profile. This is now a separate extrusion. So now we have two, right? Then what we can do is to click on both, select both together, and we'll type in join. So previously we had two open surfaces. Now when we join it, it's joined to one closed polysurface. So this is how we kind of cap a polysurface that does not have a planar loop. So far, can follow along? Okay, the next part will be now going through the first command, which is extrude curve. So let's click on this curve and extrude it. The main thing that you need to take note for extrude curve, right, is this prompt here called solid equals yes or no. So if we enable solid equals yes, the final extrusion will be a closed polysurface. You can see that all the sides have a surface to them, as well as the top and the bottom. So this results in a totally enclosed interior volume. Now let's delete it, and we'll select the same curve. We type in extrude curve again, and this time we disable the solid equals yes, so we make it equals no. And you can see that the visualization has slightly changed. Now you can see that the top and the bottom no longer has a surface to them. It's kind of hollowed through. So when I finally create the solid, right, you can see that this is an open extrusion because the top and the bottom does not have a surface. Alright? So again, the most important thing that you need to take note for your extrude curve is this solid equals yes or no. And if you want to extrude it by a certain distance, we will type in a value here. So if I want to extrude it by 500 millimeters, I'll just type in 500. And this will ensure that the solid has a height of 500. The next command will be planar surface. So instead of wanting to extrude a solid with thickness, let's say if you only want a planar kind of surface, that's when you need to first identify a planar curve such as this, and then you'll type in PS, and you can see that the result is a surface that's created from the curve that you drew. So when I click on this, it says it becomes a trimmed surface. Now let's say if you create a trimmed surface, right, and you want to extrude it with thickness, here is where you use the command extrude surface. So I'll type in ES, and it extrudes from that surface a volume instead. So in this case, I'll enable solid equals yes, and I generate a solid from the initial surface. Now we look at the second curve. We can see that there's two curves. One curve is entirely within the bounds of the outer curve. So this will generate a solid where it's hollow on the inside, and it only takes the in-between as the kind of interior space. So when I select both curves and I extrude it, with solid equals yes enabled, this will show a kind of closed volume where, as I mentioned, only the region in between the internal curve and the exterior curve is made solid. That's how the interior over here is made as hollow, and it still identifies itself as a closed extrusion. Now let's take a look at this. So we have 4 curves over here, and let's say you want to generate a solid from just the outline of the 4 curves. The step that you have to do before your extrude curve is to first curve boolean it. So we select the 4 curves, we type in CB, and we pick an outside point. So we generate an outer outline of all your curves, and I think you already know this from your exercise 1. So we need to generate the outer curve first before we extrude it. So when we finally extrude it, you can see that it is a nice solid of all the initial 4 curves outline. Okay, the next part, let's delete this solid first. So let's start by creating a simple rectangle over here, and we want to make this a planar surface. So let's say if you want to manipulate your 3D objects, right, the way that we manipulate them, usually, let's say if you want to move an edge, is we select the surface and we type in solid point on. So over here we need to type in this command, solid point on, and what it will reveal is all the edges as a point. So these points you can now move them and it will change the outlook of the surface. So let's say if I select this point over here and I move it, it will change the edge of the surface that was created previously. This works for a kind of a solid as well. So if you pick one of the previous cubes over here, right, and you turn on solid point on, when you select just the points that you want to change and you move them, it will change and manipulate the solid as well. Okay? So now I'll be teaching you something called UV parameters. So by default, when you make a planar surface, it does not have any intermediary points. That means whatever you generate, right, this surface will always be a kind of a surface that is interpolated from the 4 points. So if you want to create curvatures within the surface, it's not possible by just a standard planar surface. So the way we inject more control points in the surface is by clicking on this and typing rebuild. And here you can see that when we rebuild the surface, we can denote what's the new UV point counts that we want, as well as the degree. So the moment we increase the point count, we are also increasing the degree. So let's try to change the point count from 2 previously. The 2 previously is like I showed this point and this point. So there's only 2 on the UV plane, and there's only 2 on the V plane. So we increase this to a larger number, like 6. And we change the UV degree from 1 to 3 as well. And we will press OK. In this case, we are regenerating the surface with more intermediate control points. So here is where the magic happens. We will press F10. Once you rebuild your surface, you'll press F10. And it reveals all the UV points of the surface that's been rebuilt. So what happens in this case is we can create a more finely tuned curvature surface from this by moving the UV control points. So in this case, when I select just these points over here, right, and I move it, you can see that the change is more localized than previously. Instead of a surface that was generated just from the 4 points, it now takes in 20 points or 25 points, and it only creates a new blend. It creates a new kind of best fit surface that goes through all these points. So now when I only move these points over here, you can see that it creates a surface where it's high over here and it bends down to the other points that are not that have not been moved. So this allows for more control. So let's say if you move other points like this, you can further manipulate that surface initially that you created. Okay, so this is the difference between solid point and F10. For F10, you are controlling the control points. For solid point, you are basically only controlling the edge, the edge points. So in this case, when I press F10, you can see all the intermediate points. But when I press solid point, it will only reveal the edge points. So in this case, it's mainly for kind of moving the edge over here, and it will regenerate the entire surface based on where the edges are, as you can see. So that's the difference between solid point versus F10, which is control point. Now I will teach you the command called project. So let's say if you have a planar surface and you realize your curve is not planar to the surface that you want. So what you want to do is you make use of the command called project to make sure that this non-planar curve is projected onto the planar surface. So I will show you how to do that command right now. The first thing you need to do, let's delete the planar curve first. With this curve, right, that you have, you click on it and you type in project. And then here what you need to do is you need to indicate the direction of the projection. So in this case we cannot use C-plane Z because C-plane Z means it's going to be projected upwards, which we don't want. We want it to be projected in this direction. So it's projected in this direction to finally kind of hit the surface over here. So we need to change the direction from C-plane Z to custom. So we click on the direction prompt over here, change it to custom. And then we need to select the surface that is going to be projected to. So in this case, let's select this surface right here. Now when we press enter, they ask for a projection direction. So we need to draw a line that shows the direction of that projection. So I'll draw this line from this point to the other point. So it's drawing a projection vector this way. And you can see that now it has created a projected curve from the original curve that's planar with the surface. Is everybody able to get this? Sorry? One more time. One more time, okay. We take the original curve again. We type in project. And here we need to first set the direction as custom because we are not going to be projecting upwards or downwards. So we'll set it as custom. And then in the prompt they ask to select the surface where it's going to be projected to. So we'll select on this surface because we want to project the curve on this surface. So we select this surface right here. Then we press enter. And then they ask for a projection direction. So we are projecting this non-planar curve this direction in order to make it project on this face. So we need to draw that line. We first pick this point and we pick the second point on the other line, and this will help to generate a projected curve of the original curve. Now we can just delete the old curve because we have the new projected curve. Now, for this part of the tutorial, let's say if you want to project a curve onto a curved surface, we cannot really. I think we can also project it. So let's try to project it. We'll just try to click on this curve again. Or before that, we need to extract the surface because it cannot identify a solid poly surface. So we can do the extract surface again. And in this case, let's just make copy equals yes. So it does not subtract a surface from the original poly surface, but it creates a copy instead. So I'll click on this. I've extracted this one surface. And now I can type in project, click on the curve, and then I will click on the surface, and then for the projection direction, actually we can just project it downwards. So just now you can just pick the C-plane Z. So now this is how you project the curve onto a curved surface. So again, let's do it again. I'll click on this curve, type in project, set the direction to C-plane Z this time, select the surface, which is this one, press enter, and it now projects that curve that was not on the surface to one that's on the surface. So when you look on the top view, right? When you look at the top view, both curves have the same profile on plan, but one is now snapped to the surface compared to the previous one. Alright, now let's go through some other commands before we go into the modeling of the room. The next one will be your Boolean operations. So remember when I said if you want to make a window opening or a door opening, you'll be using a lot of these Boolean operations in order to subtract a window kind of cube from a wall surface. So I'll show you how that works right now. The first one we'll be going through is Boolean union. So as you can see, right, in this part, these two geometries, I have a cube and I have a sphere. They are separated at the moment. So when I click on both and I type in BU, it has now joined both extrusions, it has joined both poly surfaces as a single closed poly surface. So the thing that you must take note is the two inputs of your poly surfaces must be closed in the first place. It will not work if one of them is open. So I can show you that just when I take away one of these surfaces to make one an open poly surface, right? And then I join it and I Boolean union it with a closed poly surface. I don't think it will work. They say the Boolean union has failed because it only works when both initial inputs are closed poly surfaces. Okay, so that's when I thought previously that you need to make sure your open poly surfaces are closed first. Either you cap it or you create a new surface to join both surfaces such that they become a closed poly surface. The next one will be a Boolean difference. So you can think of it almost as like you have two solids, right? And you want to subtract A minus B. So from an A, you want to remove a B portion from it. Here is where you can use Boolean difference. So I'm treating my cube as A and my sphere as B. So I'll type in Boolean difference. I'll first select the A object. So I'm selecting the cube first. Press enter, and now I select B, which is the sphere. And your delete input I set as yes for now. So when I press enter, you can see that it has subtracted B from A, and this is the resulting solid. So let's say if I create multiple kinds of spheres, I make a cloud of some sort. So I create three kinds of closed poly surface. My first step is to Boolean union them. So now it becomes one single surface. And then what I can do is when I subtract away a cube portion from it, I can create kinds of more complex geometries from previously. So let's say if I subtract away the cube from this, you can see that the result of the geometry is something like this. So it's almost like I have a cloud with a balcony space over here. So that's how I can create a balcony space by subtracting a solid from it, a cube from it. Now, the other command which is not over here, but we'll also use quite often, is called Boolean split. So just now you learn about Boolean difference, right? Now the difference between Boolean difference and Boolean split is it does not kind of remove the part that is subtracted. Instead, it just splits it based on the volume that is to be kind of subtracted. So that means when I click on the cube again and I type in Boolean split and I split it with this sphere over here, you can see that the resulting two polysurfaces is the difference of the sphere. So what I have is the cube with the sphere subtracted, as well as the portion where it's the intersection between the sphere and the cube. So this is the difference between Boolean split and Boolean difference. Now, Boolean intersection is one of the products of the Boolean split, as you saw previously. So the part that is intersecting will be the result in this Boolean intersection operation. So when I click on the cube and I click on the sphere and I Boolean intersection right here. Sorry, I have to do one by one. So I have to click on this first, then click on the second one. The result is the intersection volume. Okay, so now I'll go through the last part, which is using a command called shell. So let's say you have a closed cube, right? And you want to instead inject a kind of space within it. So you want to hollow out the interior. You do that through the command called shell. So let's say if you got a cupboard that you want to model, right? You start off with a cube first. And then what you do is you shell out one of the faces to kind of reveal the interior space of the cupboard. So that's when this command shell is useful for you. So how we do that, right, is we pick a closed cube first, and then we type in the command shell. Here we need to select the faces that we want to shell it. So if let's say we don't want the back to be hollowed out, we only want this part to be hollowed out, and the space is just contained within the interior space is just contained within here, but we still have walls for all the other faces, then we only select this face as the shelling. So here we also can denote what thickness we want. Let's say we want a shell thickness of 3 mm, we need to make sure we type in 3, and this will make sure that the shell will be 3 mm thick. So when I press enter, you can see that it hollowed out the interior of the shell of the cube with a thickness of 3 mm. So we can see that the back is not hollowed out because we only selected the front face. Everyone can get the shell command? Now let's say if you want it to be hollow on this face and this face, in other words, it's almost like a tunnel, right? You want the person to be able to walk through in this opening and exit from the other opening. Then you type in shell again, but you need to select this face as well as the face at the back. So if you denote the same thickness, or I increase the thickness to 10, you can see that the result is a hollowed out solid that's open on this face as well as the back. So this is useful for, let's say, you're creating your window frames. You start off with a cube as well, and then you're using shell to open up this face and this face, so this becomes your window frame. Is everyone catching up so far? Or do you all want some time to like explore? 5 minute break. Okay, let's do a 5 minute break first. So everyone just take a while to. Okay, bye.
You putting out okay? You putting out okay?
Yeah.
What is
But
that? But
the class is dead.
yeah, I know. They look. I think they. A lot of them have chugging. They chugging like the math cheat sheet. Probably got test lah. Yeah, I don't know what. I don't know why.
Okay. Anyway, I recorded mine, so it's fine.
God bless. Gosh. How long was your tutorial? This one
Actually, yesterday very long. It's not
Very long,
full,
right?
the
full session ah?
3 hours, 4 hours, yeah.
Oh shit. So there's a lot more to go. Is it?
But the difference between yesterday and today, I guess, is yesterday everyone was following along. So the reason why I was slow is because everyone kept raising their hand and asked me to repeat and stuff. So maybe if today no one's doing that, then it might be faster.
Okay. Got it. I mean, anything also ask the TAs. Yesterday no TAs.
Yesterday got more. Yesterday had like 4 TAs.
So strange. How come kids rotating like that?
Is today like the exam day or something?
Maybe. But no, doing now capstone looks more harder. TAs.
Oh,
Yeah.
wonder they can't count.
But yeah, I guess I'm tired.
Yeah.
Okay lah.
No choice.
Morning lessons really no go. Can pass me the bag?
Okay.
Really no go for example. I don't think we made it for morning lessons.
Yeah, everyone like have fifth row yesterday, right?
Oh yeah, Friday. No.
Tuesday.
Today's Wednesday. Friday, Wednesday.
Oh, is it?
Unless you're in dance, then it's immediate.
The last was Tuesday and Friday. Can't remember. Or Tuesday and Thursday.
Even Jackson was negative. Just now, he walked past me slightly. Sorry.
Oops. Very dry.
A bit drier lah. But okay, now it's like that.
Yeah.
Next time, afternoon class only.
Afternoon class people are more alert.
Yeah. Because always after breakfast or lunch, lunch has coma as well.
It's never a good time for lessons.
Yeah, I just graduated lah.
Oh.
So yeah.
Okay, so I'll just continue on the lesson. Alright, so for this part of the lesson is teaching on the commands array. So array is when you want to create a repeated, you want to create repeats of the geometry in a row, or let's say in a certain direction. So let's say if you got a louver, you modeled one louver, and you want to array it up such that you create a whole bunch of louvers within this frame. In this case, you use the command array or array linear or array polar. So let's start off with array. What you can do is you click on two of this, and then you type in array. And for array, it's mainly locked to the x and y and z directions. So it means here you can only make use of the existing world x, y, z planes to create the array. So it's not that useful. I'll just showcase what's the effect right now. So let's say I want to create 5 copies in the x direction, and maybe in the y direction, maybe, sorry, let me just do one. 5 copies in the x direction, 5 copies in the y direction, maybe 2 copies in the z direction. And then to create the unit cell, I can just drag one point and then move it a certain distance. Wait, whoops, doesn't work. And you need to drag it diagonally. So this diagonal will help to create that that array of that geometry. So in this case, when you drag the distance diagonally, you can create that array like this, and the height as well. So when you press enter, you create an array of that single object. The next one, I think we'll be using it more often, is array linear. So array linear is you can indicate the direction of its array. So in this case, I have point A to point B, and I want to array along this direction A to B, and I can specify the number of arrays I want. So I'll type in array linear first, select the cube, and maybe I want to do about 5 items of this array. So I'll select the first reference point, which is A, and then I'll move to B, and you can see it's creating 5 copies of the original geometry with this distance from A to B. So the 5 includes the original copy that you had over here. The last one would be on array polar. So polar means you're going to be arraying it in a circle, and it's creating copies that's revolving around point A. So in this case, how you do it is you click on the object first, you type in array polar, and here you say you denote where's the center of that polar array. So A has been already defined, right? So I'll just press A over here, and then I want it maybe 10 times around A. So I'll type in 10 items. And here you need to make sure that the angle is filled to 360 if you want to make it a complete circle. Or if you only want to array half a circle, then you type in 180 as the degree. So in this case, I'll type in 360, press OK. You can see that it's previewing the 10 copies of the arrayed geometry. So when I finally press enter, you can see that there are now 10 copies of the geometry at first. Alright, so these are the 3 commands for array. Actually, before I move into how you can utilize these commands for the room, right, I will just go through some freeform commands first. So how do you create freeform objects in Rhino? So just bear with me for this part. The main commands for creating that freeform geometry, it's loft. Firstly, it's loft. Second one will be by sweeping. Third one will be by flowing it. So I will go through loft first. So let's go into loft. Let's say if you got a unique kind of bench or a chair and you got a bunch of section curves. So what I did was, on a 2D plane first, I traced out the section curves of the start, the middle and the end. So this is the starting curve, this is the middle curve, and this is the end curve. So here is where I make use of this command called loft in order to generate a surface that will go through these 3 curves, and it creates a nice kind of how to say, it interpolates between the 3 curves itself. So how to do that? Let me just delete this first. The first step that I want to do is I want to move them from a horizontal plane to a vertical plane. So with these 3 commands, with these 3 curves, right, the first thing I do is to rotate 3D. So I will type in rotate 3D here, and I will denote this rotation axis as the line here, because I'm rotating it from a horizontal position from the axis to a vertical position. So let's just denote this rotation axis like this, and then we denote the starting point of the rotation, and then we move it, and you can see it's creating an arc. So if you can see the bottom here, it's also creating the degree. So as we move up, you can see the degree increases. I want to make it totally vertical, so in this case I will need to input the number 90 to make sure that it's totally rotated 90 degrees to a vertical plane. So while this is kind of moving, the cursor is moving, right, I'll just type in 90, and you can see that now I have rotated in 3D the planar curves from an XY plane to a Z plane. Okay, so you can see that all these curves are very freeform, right? Like the way I drew it is through a NURBS curve, so you can't possibly make a planar surface, or you can't extrude these curves, because extruding these curves will be just a very straight extrusion. So you want to create a best fit kind of loft in between. Now let's move the starting curve, the starting profile curve. Let's move it to a space over here, and we rotate it to a certain direction that we want. Now we take the second curve, and we also move it to somewhere where it's the middle section of the bench, somewhere like this. And we take the last curve, and we rotate it in certain direction to make it the end of the bench as well. So we have these 3 curves, and these 3 curves will kind of be enough for you to create a loft that is kind of smooth and curved. So I'll show you in this case how it will look. So this is my starting, my middle, and my end. It will generate a loft that goes from the starting to the middle to the end. So I'll show you. When I type in loft, I'll select the curves in order. So it's important to select them in order. you need to make sure you select the starting first, followed by the middle, and then the end. So I'll click the first one, the second one, and then the last one. Then you press enter, and this step is also crucial because we need to adjust the seam point such that they can reference where each curve starts at. So that means if this is the bottom edge of the chair, right, it needs to join with the middle curve bottom edge of the chair, and needs to join with the end curve bottom edge of the chair. So as you can see now, for the second and third, it's already aligned, but the first curve, it isn't aligned. So we need to align the first curve simply by dragging this point over here. You're dragging along the curve until it snaps to the same corner as the other two curves. So this ensures that now the starting seam point aligns with the second seam point and the third seam point. So when I press enter, there's some error. Okay, so let's go back to the lofting again. 1, 2, 3. And you can see why there's a difference. It's because of this arrow over here. So this arrow also will denote how the curve is oriented. So you can see that this point starts off at the corner, but the curve starts in this direction, it goes upwards. Whereas this curve, it starts at the same point but it goes in a negative direction. That's why you saw the final loft, it looked a bit weird because it was a flipped curve. So in other words, what we need to do is we need to flip this seam point such that this arrow points upwards instead of downwards. To do that, we can see that we can just click on the arrow over here. When we click on this arrow, it flips the direction of the curve. So now you have the starting point, you have all the points at the same position, and you have all the arrows pointing in the same position. So when you finally press enter, you see that the loft is now created as how you want it. You want each profile to be lofted, and it generates a nice loft out of it. So you can see here there's a bunch of drop down bars that you can change the loft how it looks like. So this is how normal looks like. Make it loose, it looks a bit more it has a simpler curve because it does not actually go through the original curves. It creates a more kind of best fit than what you wanted. Whereas tight, on the other hand, it makes sure that it really follows the curvature and every single portion of the curve is interpolated through. So this is the difference between tight and normal. Normal, there's some leeway as well, so it's not totally tight compared to the tight one. For straight, it's slightly different, so it creates a straight section between this and that, and this may be useful for, let's say, if you want something that's not curved but something that's straight with a bunch of section curves that you already drew. The last one will be uniform, which at this point I'm not really sure what uniform does, so I don't really use it. Right, so for this purpose, I'm just going to use normal. So when I press enter, now you can see that it has created that free-form object that I wanted. And we can finally cap the two ends because it's an open poly surface, so I'll just cap it. So you can see that this portion is now filled up with a surface, and this point is filled up with a surface as well. Everyone, please have a go at this lofting and try to drag the seam points as well, so that you are familiar with how you loft it. That means in future when you do your objects, let's say you have what kind of objects will you have? Your pillows, I guess. You have your pillows that you want to model, or if you want to model out, let's say you got a soft toy, you may want to use this as well. Then should I just like monologue? Just speed through. Okay. So then we just end the class, right? Okay. Alright. Okay, so the next command that I want to go through is sweep 1 and 2. So what sweep compared to loft does is it introduces a real curve that you can kind of interpolate a bunch of section curves through. So in this case, what sweep 1 does is it wants one rail and multiple section curves. So what it does is it creates a surface that will interpolate through all the section curves following the rail. So in this case, I'll show you what it does. First, I'll select the rail curve, something like this, one closed curve, and then I'll type in sweep 1 first. And then after that, they say you can select the sweep shapes. So here is where you also have to select all the shapes in order. So in this case, I will start off from this one over here, and I'll go in a loop. So I'll start with this, and then go with the next one more, and go in a loop until you reach the final sweep shape. Then finally you can press enter, and it's the same as the loft. You will need to adjust the seam points such that all are aligned. You can see that somehow Rhino just doesn't do it that well, so you always have to adjust the loft. Always have to adjust the seam point. So in this case, let's take the middle seam point over here, and we adjust the rest that are not in the middle, like this. So I will make sure that the directions are also all the same. So I'll just move it down. I'll move this down as well. This one down, and then this one to the middle as well. Okay, so I have all seam points they are accurately aligned. Now when I press enter, okay, so I can see that this is the result that I wanted. All the sweep profiles align, so there's a nice top surface, there's a nice slanted surface that never kind of goes haywire, and all the way through all the surfaces does it nicely. So here is where you see that there's a gap that's not filled up, right? Because by default, sweep 1 will only take the initial sweep shape and the final sweep shape and create a surface through that. So the difference is that for, let's say, if you have a sweep curve that's a closed curve, what you can do is you can enable closed sweep, and it will create that final portion over here that connects the end curve to the starting curve, so that your poly surface will be all closed in the end. So when I finally press OK, you can see that this is the solid that's been generated. It's been closed all the way through, and it goes through every single sweep profile using the real curve that I inputted. Alright, so this is for sweep 1. Now for sweep 2, the difference is that instead of inputting one real curve, you are inputting two real curves. So this can generate more accurate kind of sweeps that you want. But this is only for, let's say, you have two kind of real curves that are flying everywhere. So if you don't want the bottom real curve to have the same profile as the top real curve, that's when you need two real curves. And this is when sweep 2 is useful. So the process is the same. You type in sweep 2 first. You select the first rail curve as I have at the bottom, and then you select the second rail, which is at the top, and you need to select the sweep shapes in order as well. So I'll go from this point and go in a loop. So you can see that as much as possible, all the sweep shapes are being interpolated through, and it's trimmed at the top curved and the bottom curve as well. So this creates quite a nice smooth surface based on the curves that you inputted, except for this part. The reason why this part goes haywire is because for these two sweep shapes, I did not join it to this bottom rail. So maybe I should just join it to show the effect. So let's just join it like this. And let's try sweeping it again. So this will ensure that all section curves are always joined with the bottom and the top curve. I sweep 2 and I go in a loop. Sorry, I selected one wrongly. When you select one wrongly, you have to redo the whole command. You can see that it has generated a sweep that follows all the section curves I wanted, and here it almost creates a kind of like a seating kind of bench, because for these two section curves I have made this section curve as such. There's a horizontal portion and there's a diagonal portion, so that's why this part looks like this compared to the rest. So for sweep 2, you're also able to create a closed sweep if you want, based on the prompt that was the dialog box that was open just now. Right. Okay, so this is for the sweep commands. Now for the next portion will be flow. So flow is, let's say you have a planar kind of objects. You have planar objects and you want to instead morph them onto a sweep surface. So let's say you just have a sweep surface like this, and you want to create a kind of pattern of your planar pattern onto the sweep surface. This is when you use the flow command, or flow along surface. So what I'll do is I generated the original pattern of all the rings that I have here. It's on a flat surface, so I also have the flat surface inputted. And then I want to morph all these rings onto this sweep surface that I created. So in order to do that, I will type in flow along surface. So first they ask for select objects to flow along a surface, and here is when I will select all the rings minus the base surface that's underneath. So I will make sure the base surface is not selected. Make sure I select all this and I press enter. Then they ask to first select the base surface. That's why I created that planar base surface. So I need to select a point on the starting first. So I'll select the starting point somewhere, it doesn't have to be accurate, just somewhere at the beginning of the surface. Just click on it. And then you want to select somewhere on the sweep surface as well. And that will correspond to your starting point as well, I think. So over here, I'll maybe want to start this ring somewhere here. So I will click the surface like this. So you can see that what happens now, let's say if I delete this sweep surface, it has morphed the existing rings that were planar initially to the sweep surface, creating this pattern. Okay? So this is also useful for, let's say you've got some patterns on your object that you want to kind of show the thickness of it. You start off with a planar you start off drawing or modeling out in a planar way, and then you model out just a simple surface in 3D first, then you morph the pattern objects onto the sweep surface. So that's how you can generate some patterns out of your sweep surface. Now that was flow along surface. So flow along surface, the difference was that you inputted a base surface and a target surface, whereas for flow, what it does is it takes a base curve and a target curve. So it doesn't use surfaces as an input, it uses curves as an input. So this is what the output can be. Let's say you have a straight object, right? A text object that is straight, and you want to morph it along a NURBS curve. That's when you use flow instead of flow along surface. So I'll demonstrate this. I'll pick this text object first. I'll type in flow, and I will first input the base curve, which is what I already drew. I drew a base curve that's following the direction of the object. So I'll click on this base curve, and then maybe I'll pick the target curve somewhere along this point. So okay, you can see that it will always start from the start of the curve. So for this, I should probably split the curve at this point if I want to start it from here. So if I want the testing, this is a long sentence to start from this, I need to split the long curve to this point first, and then I'll repeat the command flow. I'll input the base curve, which is that straight curve over here, and then I will input the target curve, which is the start of that target curve. You can see that now he has morphed itself to the curve. Okay, so this is the function of flow and flow along surface. The last command that you probably use is patch. So patch, what it does is it takes a network of curves and points, and it generates a best fit surface out of all the inputs that you give. So for example, something like this, right? What I need to first have is a kind of a network of curves. So I need to have at least this edge drawn as how I want it. It doesn't really have to connect. It can be slightly apart, but at least I know that this is the edge that I want. And then I draw out the other edges as well. And then I can draw a bunch of intermediary curves as well to denote maybe the curvature in the middle. So this will help to generate a patch surface that has all this as the outer edges, and then maybe this curve as the intermediary profile that I want. And then in addition to that, let's say at this portion I want the surface to be at a particular height. I can do that by injecting a point over here. So my final input, right, for all this will be just to select all this. I'll type in patch, and over here it's creating a patch or a new surface based on the number of U and V spans that you want. So for a start, maybe 10 U spans and 10 V spans is enough. So I mentioned previously, right, you have a planar surface with only a UV span of 2 each. So you rebuild the planar surface to increase the number of UV spans. In this case, you are generating the number of UV spans here by this number. So when I press OK, if the points are not connected, I mean if the curves are not connected, you end up having a surface that's larger than all your points. So eventually what you make of this surface is you have to trim it based on the profile that you want. So the difference is, let's say if you join all the network curves like this, right? So if you have all 4 curves that are always joined at its edges, and you input this as a patch again, you can see that now it creates a nice patch that has all the curves here as the edges. So this is the difference when the curves are connected versus when it's not connected. Okay, so far I can get it. So this is for patch. We've gone through loft, sweep, flow, and patch. For twin curves and surfaces, probably it's not as important now, so I won't go through it. Alright, so let's go through how you model your room. Maybe for this I'll take another 5-minute break before I go on with it. So everyone can make use of this time to either, if you are in Rhino, can make use of this time to just explore the commands over here. And I'll resume with the room in 5 minutes time. just flow? Is
Just
it?
flow.
Patch,
just
yeah?
flow.
Patch.
Patch, I think okay.
Okay.
Yeah. Not intuitive. Just flow also. I went to the toilet for a moment. Then I came out, someone asked me flow. I was like, oh shit, that was like not for me.
Oh, okay.
Then Justin, it's Justin, is it that TA? It's that TA, right?
Isaac.
Oh, okay,
Isaac.
okay. So many TAs.
Yeah.
Yeah, they also do got error.
They have error for the flow.
Yeah, it ended up being projected on the seaplane. But it flows along the curve like it's on your seaplane.
Oh, of course they. Oh, I know. Because they didn't use flow along surface. They use flow.
Ah yes. Oh,
That's
okay,
why.
yeah,
Okay, let me resume my tutorial. Right, so I'll just go through flow one more time. So there's two different types of flows. One is called flow along surface, which takes in just an input of a curve and output of a curve. So if you want to map, let's say, a more three-dimensional object onto a surface, right, you cannot use flow. You have to use flow along SRF. So in this case, what you do is you first draw out all the rings or the pattern that you want on a planar surface first. And you also need the planar surface itself as an input. So finally what you have is you also will need the sweep surface, which is that target surface that you want. So these are the three inputs you need. You need the tessellated surfaces, you need the input base surface, which is a planar surface, and you need the target sweep surface, which is that three-dimensional surface. So when you type in flow along surface, you first select all the objects of the tessellation or the pattern. So in this case, it's all these rings. I select all of them and make sure the base surface is not selected. So I'm just make sure all these are selected. And then what you do is you type in and you press enter. You first click on the base surface. So that's when you click on this planar rectangle surface that you had. Click something like this. And then finally you just need to click on the target surface. So I think in this case just click on a point where you want it to start. So in this case I want it to start here. hopefully it works. Wow, this is taking intense. What's happening? Okay, something wrong happened. Something went wrong. Let me try again. Right, so I think it's a matter of where you click your target surface. So sometimes if you click it on the wrong axis, right, then it ends up generating a totally different pattern as what you intended. So if that happens, just undo and click on another point such that you can generate the morphing as you wanted. Alright, so let me move on to the room modeling now, and this will be my workflow. So I think for the purpose of this session, I'll just do it at my pace lah. So if you don't manage to catch, don't worry, the whole thing is recorded, and then you can just rewatch it. Or if you really want me to stop while you try out certain stuff, just raise your hand and let me know. If not, I'll just go through the whole thing like a monologue in a way. So I start off with my floor plan that I had, and with my layer structure, right, I will make use of the way I'll draw all my surfaces in the layer that I want. So first of all, what I need to do is to create the wall as well as the floor. So to create the wall, right, let's go to my wall layer curve. I will need an inner and outer curve. So when I have these two curves, I can extrude them to create that poly surface with an exterior and an interior wall with a hollowed out interior lah. So to do that, if all my curves are very kind of like ravak, right, I will want to just heck hair the drawing first, lock everything, and just draw and trace over the outer and the inner curve. So in this case, I'll start with the outer wall first, and I'll start to trace the outer wall. So my outer wall, based on this drawing that I did, right, is a very simple rectangle. So I can just draw a polyline that snaps to all the corners. So I finally have, very easy, I already have my outer curve already. So now I also need to draw my inner curve, and this one is a bit more articulated because the columns and the walls have different thicknesses. So here as well, I'll zoom in and I'll trace more in depth. I'll make sure I trace the inner wall like this, and then here there's a protrusion as well, and here there's another protrusion. So I'll make sure all these are captured. And the drying cabinet, so I need to make sure that the width is aligned nicely. And this part, there's another column, so I need to protrude it out again. And finally, make it a closed curve by snapping it back to the original point. So as you can see, now I can select the two curves sui. It's like there's two closed curves. So previously I mentioned, right, this part is also quite crucial because what you want is you don't want to create a continuous wall surface. If you remember all these examples, right, over here, all these examples, there's always two walls that are hidden and the other two walls are visible. So you will want to separate them right at the start. You will want to create two poly surfaces instead of one continuous poly surface. So in this case, I will first have to decide which direction I want to showcase. In this case, most of the examples that I see on previous years is they always have the windows showcased in one of the walls, and then the other wall is where they put their bid. So in this case, I will want to follow a similar kind of workflow. I will decide on this direction. So these two walls will be the visible walls, and these two walls will be, I'm sorry, I was looking at it wrongly. This is the window and this is the door. So these two walls are the two visible walls that I want to show, and these two walls will be the hidden walls. So they will be kind of shown in dotted lines in my case. So if that's the case, right, what I need to do is to first demarcate a line that separates that two walls from the other two walls. So what I will do is I will draw a line over here. This will demarcate a separation between this wall and this wall, and I need another line on the other corner as well. So I will draw another line over here. So in essence, now I have separated that continuous boundary into two separate regions. And with these four curves that I have, I will use the curve boolean function to create the new two regions. So I will start off by creating this region. And you can see that I've nicely created that closed curve. And I will need to do the same curve boolean for the other region. So I will type in curve boolean over here. And I will click on this region over here. So as you can see, now I have two closed curves that denote all my wall surfaces. So I will go back to my layer properties, go to the wall layer in this case, and I will extrude it by a certain height. So in this case, you need to measure the height of your own room, and you will measure from your floor to your ceiling, and that will usually be the height that you extrude your isometric towards. So in this case, I will take the height of my floor to ceiling as around 2.6 meters, so I'll do 2600. I'll select the two curves that I've curve boolean out just now. The first curve being the one that's going to be the hidden wall, and the other curve being the solid wall that will be at the back of the isometric. So I will select these two curves. I will type in EC, which is short for extrude curve, and over here I will type in the extrusion distance, which is 2600. So this is how I generated all my wall poly surfaces, and you can see that this solid is separate from the other solid. So in essence, eventually, right, what I can do is for this solid, I can make 2D separately in a different layer, and then I can denote this entire wall as a hidden line rather than a solid line. So far you can understand the workflow. So that's the whole purpose why I want to separate the walls at the back and the walls at the front. Okay, maybe I'll give you some time to try it out if you want. So just if you're working in Rhino, just spend 3 hours trying to trace out the inner and the outer walls, and then curve, and then you take note of the two lines that I draw to demarcate the separation. So it demarcates the two walls at the back from the two walls at the front, and then I curve booleaned it, and then I extruded it. So you want to try it? And I think for this, I also want to extrude the floor. So I'll take the outer wall curve. Hopefully I can select the outer wall curve over here. And I'll go to my floor layer, make it active. And instead of extruding it upwards, I know that my datum kind of floor level is at 0, 0. So instead, for the isometric, what I can do is I want to make the floor have a certain thickness, and I'll extrude it downwards instead. So in this case, I'll extrude the outer wall curve downwards by a thickness of perhaps the same thickness as your wall. So maybe 200 or 300 will be enough. So in this case, maybe 300. So now in essence, I have three solids that I created: the back wall, the front wall, as well as the floor. So in other words, I can remove this and I can just review the back walls and the floor. So eventually when I start modeling, I can just use this as to model. Okay, now let's make use of our first Boolean operation, Boolean difference, to create the window openings and the door openings. So as you can see, there's these windows over here. For the hostel, there's also the louvers, and there's the door, right? So it's using the command called Boolean difference to subtract away from the extruded walls that you have. So in this case, what I need to do is to first go back to my floor plan, and then create some kind of cubes that denote the windows and the doors, and then use those cubes to subtract away from the wall. So let's go back to the floor plan. I will move away all these walls that I created first. So I'll just move them from the top of the rectangle to the bottom of the rectangle, so I can easily access my floor plan again. And what I want to do now is to trace over the window openings as well as the door openings. So I'll go to my door layer. Doesn't matter which layer that you build your objects, because eventually I'm going to delete all these boolean surfaces. So what I'll do is I'll just trace over all the openings on the plan. So let's start off with the window. So at the window over here, I want to draw a rectangle from the bottom corner of the left window to the top corner of the right window. So I'll do this box over here. So I have one done. And one important thing to take note is, for all boolean operations, right, make sure that the solid that you create does not is kind of like exceeding the proportions of the wall surface. So the reason you want to exceed is because if you do a surface extrusion like this, and you subtract it away from the wall, you might not achieve quite a nice opening, because the some of the curves may not overlap, the solids may not overlap nicely. So in this case, you may want all these curves to be overlapped slightly more, such that when you subtract it away from the wall, it's nicely subtracted away from the wall. So once I created this curve, right, the best way to do it is to do a scale 1D, and to make this curve slightly fatter than the proportions of the window. So the way I do it is to scale 1D, I select the base point as the midpoint of the short edge, and then I will snap to the one of the corners, and then I'll just purposely kind of scale it larger than the proportion of the wall over here. So I make it slightly larger. So I've done it for one window, and then I'll just copy this rectangle to the other window as well. So I'll just bring this to the other side, and now I have two rectangles that denote the openings for the windows. I will now do the same for each louver as well as the door. So I'll go to the other side over here, and I will draw a rectangle that denotes the bounds of the louvers. So I have one done here, and I copy this for the 4 louvers that I have. So this will be my second rectangle that I'll subtract away. And for this third rectangle, I can just do a scale 1D to span the entire width of the 2 louvers as well as the door. So I will just scale 1D this and make this much larger until it touches the other door frame, other louver frame over here. So I have now 5 rectangles. Now I will need to generate the solid. So in this case, for the doors, I know they are extruded from the ground. So in this case, I can just keep the starting curve at the ground level, and I'll extrude it by the height of the door. So I'll take these 3 curves, and I'll measure the height of the door in your room. So the height in your room will probably be, the height of the door will be probably 2000. Usually it's 1.8 to 2000, the height of you plus a bit higher. So I'll extrude these curves by 2000. And then for the windows, I know that they do not start from the ground. They start from your sort of like the waist height, which is around 1.2 or 1.3 meters. So in this case, you cannot extrude it from the ground. The first thing you need to do is to take these window curves and move them up to the waist height. So in this case, I will select both window curves. I will click on this arrow, and this will allow me to move up by that direction by a certain amount. So I will type in the distance. I want it to move up by 1000, because the start of the window is at 1000. Just now I said 1.2, but it's up to you to measure. So for this demonstration, I'll just move it up by 1000. So now the windows are starting at a height of 1000, and you need to extrude it by the height of the actual window. So the actual window maybe is about 1.5 meters, and here you extrude the curve by 1.5. 1500. So in other words, these are all the solids that you have. Then now let's bring back the walls. So you bring back the walls by moving again from this corner of the rectangle back to the original corner of the rectangle over here. And you can see that now all the Boolean solids of your windows and your doors are nicely overlapping the wall surfaces. So this is a good indication that your Boolean operation will be successful. So let's just try first. Let's do a Boolean difference. We type in BD. And then remember the A minus B, we start by selecting the A surfaces. We'll start by selecting the wall. Press enter. Then we will select the B surfaces, which are all your window solids. So I'll select this one, this one. And when you press enter, it subtracts away from the wall. So now you have a nice opening from your wall previously. Okay, this part. Then I'll do the same for the other face, which has my doors and my louvers. So again, type in the command BD, select the wall first, press enter, and then I will select all the solids that I want to be subtracted away. So these are the two louvers, and this is the door and the louvers. So select these three, press enter, and now you have these three solids subtracted away. So this is kind of like the starting point that you need to have for your windows. And let's say if you make a mistake, maybe the window's not supposed to be 1.5, maybe it's less than that. Then here is where you can use the command that I taught you just now, solid point on. You can change the solid points of the wall to change the height of the window. So I'll show how you can do that. You click on this window. You know that this height is 1.5, right? But maybe you check again, maybe the window is only 1.2. Type in solid point on. You can see that all the points of all the edges are shown. So what you want to do is you just select the points of the top part of the window. Select these two over here, and then this one, and then the other four as well. This one and this one. Then when you select these 4 points, now you can drop them down by the distance. So initially it was 1.5, right? You want to change to 1.2, you need to lower it by 300. So I'll click on this arrow again, click on this arrow, and then if I want to drag them downwards, you need to put a negative for your value. So you type in negative 300. When you type in negative 300, you can see that it has dropped the solid by 300. It dropped the solid points by 300. Alright, so that's how you create your openings. Now let's go through the architectural modeling. So I will start by modeling the windows, followed by the louvers, and then the door. Okay, so let's go through the windows first. Let's go to this side and show the windows. So for your windows, it's using all the operations that I taught you just now in the little tiles that we went through in the first half of the class. Let's start off simply by drawing a cube, or not a cube, a rectangular extrusion that fills up this entire opening over here. So let's go to your window. We start off with a rectangle that spans this same width as the wall. Okay, now what we can do is we take this rectangle and we extrude it to the top of the window wall. So now we create this, and this will be my window frame. So I'm going to use this window frame, and now it's not a window frame because it's not hollowed out yet. So to make it hollowed out, what you can do is to use the shell command. I will type in shell, and then I will measure the thickness of my window frame. So my window frame, maybe if you measure, maybe it's about 5 cm. So here is where you put your thickness as 50. Remember, it's in mm, it's in 50. And then you select the faces to be removed from the closed body surface. So to make it a frame, I need to select this face as well as the inside face. So I'll click on this and the inside, and I will press enter. And now I've created that hollowed out shell. So this almost denotes the kind of window frame that I want. And I can simply copy this to the other side, but I'll do for one window first. So you know, for all windows, right, it's not just having a window frame. Within the window frame, each window panel also has a frame. So I'll need to model that out as well. So it's the same workflow again. This time you start with another rectangle here, and then you snap it to the middle, and then you extrude it out to 1/2 and to the height of the bottom of the frame, something like this. And you do the same operation, which is shelling it, but you know that for the inner window frame, right, it's not as thick as the outer window frame. So maybe the inner one, as you can see, the one that contains your handle, right, is maybe only about 2 cm, so about 20. Just change the thickness to 20 over here, and select the 2 shells again. I mean, select the 2 faces to shell it. So I'll select these 2. Then you can see that I've shelled out the 2 faces to become this hollowed out solid. And usually for the secondary window frame, right, it's not as thick. So in this case, I will want to scale 1D such that it matches the thickness of your window frame. So I think while the outer window frame is actually the width of the wall, right, the inner window frame is actually much thinner. It's about 3 or 4 cm. So in this case, you grab this and you scale 1D, and you input the distance, which is about 30 or 40. So I'll go 40, and then you can see I've created the window frame that's about 40 cm thick, 40 mm thick. So I've done it for one side, and I'll just copy this to the other side. So now I have 2 window frames, and I can use the rotate command to make it open rather than close. So in this case, just grab this first solid that you have, rotate it, and then you snap to the outer point here for the center of rotation, and then you move it, and then you rotate it outwards by a degree of maybe 60, I guess, -60. Same for this side. Then we should probably have different angles as well, so you can make them have different angles. So now this is essentially what you need for your windows. You don't need to actually model out the glass panel itself, because it's going to be transparent, right? So you don't actually need a surface there. So I think just 3 panels is enough. So once I have these 3 done, right, I can just copy this entire thing. I group it first and I copy it to the other side. So I'll just take this, copy, snap from this point, which is this edge, and move it to this edge. So now I have 2 sides of the window that are modeled out. Okay? Now the next portion I want to model out is the louver. Actually, how about I give about a 2-minute break for anyone who wants to try out modeling out the window to try it out. So yeah, just try it out if you have the time. So I'll just move on to the louvers now. So for the louvers, it's the same thing. I want to create the frame first, and then for each louver kind of surface, I need to array it such that it creates that effect where it looks like you can tilt every single panel of the louver, right? So I need all the panels arrayed. So let's start off with the frame first. Go to our louver layer, and then what we do is we will start off with a rectangle, same as always. We always use the shell command. I mean, there's multiple ways of doing it, but I'll use the shell command for this tutorial. And then we drag it to the width of the two sides of the wall. So when I have this curve done, what I'll do is I'll extrude this curve up to the top of this, and then I will shell it as well, because I know the thickness of the louver frame is quite thin, right? Maybe it's about just 3 cm, so maybe 30 like this. I'll grab this face and the other face over here, so I create a hollowed out solid. And then for the next point, what I want to do is I want to create each louver panel. So the way to do this is to grab the rectangle first, and then I'll make sure I create a surface that's within the bounds of this inner bottom surface over here. So I create a rectangle like this, and then this step, before I create a planar surface, right, I want to create the angle of the louver first. So what I can do is I can drag these 2 points, and then what I can do is I can move these 2 points up such that it looks like the panel is at an angle, something like this. So when this curve is now at an angle like this, I will finally use this curve to become a planar surface, as you can see. So I have one louver kind of done now. If I want, I can create some kind of joint at the side as well. So maybe I'll just do a joint at the side. Let's do one where we do a 3-point circle. We start off from the midpoint. We snap to this edge as well as the okay, sorry, let's just do a circle and then a radius of 0.05, something like this. Okay, so I have this circle that's something like this on this plane. I want to rotate it 3D such that it's perpendicular, or like same plane as this surface over here. So I'll do a rotate 3D, and then I'll rotate this from the middle axis such that it goes from a horizontal to a vertical position. And then what I'll do is I'll extrude this curve by some certain distance, maybe very very small, right? It's about 2 or 3 mm, 5 mm, something like that, very small. So I have this piece done, and right now I will mirror this piece such that it also appears on the other side. So I'll do a mirror. So I have these 2 pieces over here, and for this final louver, right, I want to make sure it doesn't intersect all these joints that I created. So I'll just do a scale 1D, snap it from the middle, go to the edge, and over here I can slowly move this cursor from the edge to the edge of the circular joint over here. So make sure it ends before the joint. So again, from the beginning, right, I just need to drag it along this line, and I can eventually go to the edge of that circle over there. So finally I create something like this. So I'll select these 3 pieces and I'll group it first. And here is when I'll use array linear. So using array linear, right, what it does is it creates multiple copy along an axis, and you can also say how many items you want. So I'll use the array linear function over here, and I'll just give an excess number first. So you don't really know the number, but just give a large number such that eventually you can delete away the excess. So I'll just give a huge number like 50. And what I'll do is I'll start from an initial point. Maybe I start from down here. Just click on the initial point, and then your next point you just need to drag up along the z-axis, and once you're aligned with the z-axis you can actually write down the distance. So here you can type in the distance. Maybe each louver is about 40 mm apart from each other. That's when you can type in 40, and it will automatically make the height or the distance between each louver 40 away. So when I finally press enter, it creates a whole lot of copies in the vertical axis of the original geometry upwards. And then I think with this 40 mm difference it managed to hit the top. So now I got some excess, right? It doesn't matter, I can just delete them. I can just delete this. Just select the parts that are exceeding the frame and delete them. So now you've kind of managed to create one single louver already, and this is almost good enough for you for your Make 2D. So I'll just take this entire object, I'll group it, and I'll just copy this for all the other 3 louvers that have not been modeled, since it's enough to model one and just replicate it on all the 3 positions. So I'll take this corner over here, use the copy function, and I'll move it to this corner over here, move it to one over here, and the last one I need to snap it to this corner over here. Okay, so now I have 4 louvers. I have the walls and I have the windows. So let's go on to the door. For the door, I know that there's a interesting sweep profile here. You can see that the way everyone drew your door frames is with this kind of L-shaped profile, right? It's not a nice rectangular section. So in this case, maybe shelling all this doesn't help. You may need to use another command in this case, and I think the best command for this would be sweep 1. So sweep 1 takes a sweep profile curve and it takes the real curve. So what I want to do is I want to sweep this profile vertically up, horizontally, and going back down. So I need to create that real curve of that 3 lines. So in order to do that, I already have my sweep profile curve over here. So actually I don't have it because I locked it, so I'll just trace it again. What I'll do is first I'll create the real curve of that 3 lines. I'll go from the bottom, snap to this bottom of the louver frame, go vertically up until it hits the top of this door frame. Then once I hit to that point, right, I can go horizontally, go to the other louver frame on this side, snap it here, and then go back downwards until it snaps back to the bottom of the other louver. So this creates a polyline that I wanted. This is going to be the rail. It will go up, it will sweep upwards, sweep horizontally, and sweep downwards. So now I have the rail curve, I just need to do the sweep curve. So I'll just trace over what I have here. I'll just do a polyline, and I will trace this door frame. Okay, so I've created the door frame sweep curve. Now let's apply the sweep 1. So I'll use the sweep 1 command, and they say select the rail first, so let's select the rail, and then let's select the sweep shapes. We have 1 sweep shape, so we just need to select that single one, and then press enter. And because there's only 1 sweep shape, there's no seam point to adjust, so it's fine. Press enter one more time. You can see that it's sweeping along the rail with that profile. So all this you don't have to change actually. When you press OK, you can see that it has created that door frame with that profile, that L-shaped profile. So everyone can see that there's this L-shaped profile. This L shape goes up, it goes horizontally, and it goes down over here. Alright, so this is good for me. Finally will be the door. So let's just do the door right now. For the door, I'll be doing 2 commands. I'll be doing 2 objects. I'll be doing the main door frame, and then I'll be doing the handle. So let's start off with the main door frame. The main door frame is pretty simple. You just need to have a rectangle, and you extrude a rectangle. So let's just draw that rectangle on plan over here. So we take a rectangle, and we draw it from this corner, snap it to the other corner over here. you can see that this door is within the boundaries of the inner L shape profile. So this is how the door will actually work, I think. So once we have this rectangle, we just need to extrude it upwards to this inner portion as well. So we just extrude it to this piece. Okay. So actually, we already created the door. So now let's just do the handle. So for the handle, what I want to first start off is by drawing it on plan. You first want to start off with a plan drawing, and then you orient 3-point it into the actual 3-dimensional plate. So what I will need to do first of all is to create a copy of this door. I'll just type in copy, and I'll drag this somewhere further. And I know that this door is vertically up. I can make it flat by rotating it 3D. So I'll rotate it 3D first, and I will snap from the top and bring it 90 degrees flat horizontal. So something like this. Okay, this is good. So with this copy that's flat on the 2D plane, I can go to my top view, the top view of my 2D plane, and now I'll start to figure out the profile of that door handle that I want to draw. So I know for all door handles, there's usually this circular ring followed by the handle, right, which has this kind of ellipse shape. So I'll start with the circular ring, which is circular in shape. I'll start off with some construction lines. I know that the handle is probably 100 mm away from the edge of the door. Maybe 50, maybe it's not that much. 80 mm. And then from 80 mm, I know that the height of the handle is 1000, probably same height as your waist, usually 1000. So I need to start my ring at this point. So this is the construction point. I start with a circle, and what I'll do is I'll draw a circle with the ring. Radius, I'll put it as, let's see, you need to measure all this. So for the radius, I'll put it as 20 mm, I guess. Too much. 20 mm. Is it 20? 25. Usually the width is 5 cm, so I'll put 25 mm. Okay, so I have this ring that I already have. Then the next thing I want to do is to create the ellipse profile. So for the ellipse profile, I'll just use this. Just create from the center of the ring as well. Then I'll just roughly agak the dimensions. So for now, I won't measure it, but I'll do something like this. So this will be the door handle. Maybe if it's slightly bigger, you can adjust later on. Not sure. Something like this. Okay, I have these two things that I want. Now I can do an orient 3-point. I go back to my perspective, and I do an orient 3-point. So I'll do copy equals yes. I'll snap from the origin to the x-axis and the y-axis, and I'll do the same origin, x-axis, y-axis for the 3-dimensional door. So from this corner, going on the x-axis and the y-axis, you can see that I've created the profiles of here already. So for the ring itself, I can just simply extrude it, but for the handle, right, I know that it has a profile. I will probably want to sweep it because it has this L-shaped profile, right? It first emerges from the door, then it goes to the right hand side on the screen. It goes out and then it goes here. So I'll need to draw the rail as well. Currently I haven't drawn the rail, so for this rail I'll just roughly agak a rail as well. I'll just go from I'll start from the ground here. I'll just draw maybe 50 mm going outwards, and then for the length of the horizontal portion, maybe it's 100 mm. Okay, maybe something like this is enough. And then I'll just move this to the center of the circle. So I'll just need to type in move. I'll drag from this corner first, and then I make sure my selection filter is enabled to center, and then I'll move it to the center of the circle, as you can see over here. Oops, again. So I move from this end, make sure circle is enabled, and then I'll move it to this center. Okay, So now I have all the construction lines that I wanted. I have the original ring, I have the profile of the handle, and I have the rail of the handle. So let's start off with the rail of the, let's start off sweeping the handle first. So we can do some, if you want to fillet this, it's up to you, but I think I will not fillet it for now. Let's just do a sweep one. I'll select this rail, and then I'll select the sweep shape, which is this profile over here. So when I finally do that and I press enter, I've created a handle like this, and I'll press cap it to cap the surface. And then for this ring, I also need to extrude it by a certain distance. That's your keyhole, right, usually. So I'll just have this ring over here, and then have a very thin width of maybe 10 or less than that, 10 or 10. Okay, so I've created a handle for the door. So this is all the objects that I need for the door, and I'll just need to mirror this on the other side. The other side doesn't have it yet. So to mirror this, right, let's just grab the handle, and let's grab this door, and let's just move it away from the walls first by a bit. Let's just move it away by 1 meter. We can move it back later, but then this, when I move it away, right, now I can use the midpoint and the midpoint that I see in the door to mirror it. So I can select this handle over here, and then I can type in mirror. So with the mirror plane, all I need to do is select the midpoint of the door, and then select the midpoint of the other door at the other edge. You can see that it creates a mirror. And make sure your copy equals to yes. So when I have this done, you can see now it's created a mirror copy that's on both sides of the door. So since I have these two done nicely, I can just group everything and move this back by 1000. Because I moved it out by 1000, I move it back by 1000. And then finally, to show that it's a door, it's best to show it as open, in the open position. So I will rotate the entire group over here, and I will snap it to this edge over here. So I will snap the center of rotation to here, same as your floor plan drawing. And then first start with the axis, which is horizontal like this, and then I'll move it out and follow the plan drawing. So I want to move it to this edge. So now I have finished modeling out the door at its open position with the handles. Alright. Now let's just do the let's do the modeling for the other cupboards, the bed and the table. Firstly, if does anyone want some time to do this model? If not, I'll just move on. I guess not. So I'll just move on. Okay, so let's go on with the cupboards right now. So for the cupboards, right, the same thing can be applied. We will start off with a solid extrusion, and then we will shell it such that we make it we sort of like expose the interior space so that we can put stuff inside the cupboards. So we'll need to apply the shell command to it. So let's start off by tracing the cupboard first. So in this case, let's create a new layer called cupboard. Press OK, make this active layer, and I will trace the cupboard. So make sure I trace it nicely like this. And if the points doesn't match, it's best to adjust the points here. Okay, so I have this, and then I'll need to extrude it by the height of the cupboard. So the height of the cupboard will be around 2000, right? 2 meters. Is it 2 meters? Yeah, around there. 2000. Extrude it to this height. This will be your base poly surface that you eventually start to do a lot of modeling with. So when you have this cupboard drawn, I want to shell out this face, so people will know that you access the cupboard from this face. So you can shell it from here. I'll do a shell. I'll add a thickness. So for thickness, you need to measure your cupboard thickness, which is around 20. And then I'll select this face to be hollowed out. Something went wrong. Okay, what happened? Sorry, let me redo the curve. So if the curve is not planar, that means by some issues, let's just try projecting the curve first, and then we will extrude it again. Let's try shelling it. Hope it works. Okay, if it doesn't work, right, then let's just delete the surface and draw it again. So I'll extract this surface because I don't like this surface. And then what I will need to do is just to cap it. So I think if I cap it, it should work, right? No, it doesn't work. So let's get the outer ring and the inner ring. And the way I can extract the lines of the surfaces is by using dupe edge. So I'll use dupe edge command here. I'll drag the I'll make sure I select the edges that I want to be duplicated, the inner and outer one. Alright, so I have these 8 curves. They are all individual curves. I first need to join them. You can see that, oh, there's one closed curve and there's one open curve. Why is that? Which one is the open curve? This one is open, so we can close this curve by doing a closed curve, and then we can finally do a planar surface, right? So when we have these two curves selected and we planar surface it, now we have the outer surface, the inner surface, and we need to select this bridge as well, and then we join all of them, and you can see that now it nicely joined into a one closed poly surface. Can you all see the text? It joined to one closed poly surface. One closed poly surface. Alright, so okay, this is what I want. Let's just go back, bring this back to the actual floor plan area. Now we have this, right? So first step let's do is to draw out that platform where it demarcates the drawers at the bottom from the big open space at the top. So the big open space at the top is where you hang your clothes, right? And then you put some of the clothes on the platform as well. So let's create that platform. What we can do is simply to do an extract surface, put copy equals to yes, and select this surface over here, because this is the surface that will be some height above as well. So we take this and then we push it up by a certain distance. So you measure out the two drawers at the bottom, maybe it's 250 each. So I have 250 and then another 250. So this will be around 500 up. So let's bring up by 500 first. Then what I'll do is I'll model out the drawers. So to model out the drawers, let's do the same rectangles and shelling. So let's go to the first drawer over here, do a nice little rectangle like this. So I got this rectangle over here already. And then I'll extrude it by 250 as I measured previously. So this is how I do my drawers. And actually what I realized is the doors are actually slightly protruded out. So actually it doesn't flush with the, I mean this surface isn't actually on the same plane as this wall. This thing should be slightly protruded outwards. So I will do a Boolean union in this case. What I'll do is I'll select an outer rectangle like this. Maybe a thickness of 20. And then I'll move it up to this starting of the drawer over here. And then what I can do is to extrude it to the same height as the drawer. So I want this, and then I'll Boolean union both together. So in other words, this is kind of what I want, because usually this is how it looks like. The cupboard panel is behind, and then we have the cupboard drawer that's protruded out. So this is what I want. And then for the drawers, you should also shell the top surface so that it reveals a crevice that you can put your clothes and stuff. So let's shell the top surface here. We'll click on this one, and then the thickness just put as 20. If it's not solid, whatever, it's fine. Just leave it. Alright, so we got one already. And then just as a tiny little detail, I want to do a notch here to kind of show that you can pull out the drawer. Because for most drawers, there's this detail, right? It's not just something like that. So I will create that notch again by drawing in 3-dimensional space. It has this rectangular profile that's offsetted inwards a bit. So for this, what I'll do is I'll grab a rectangle. I'll do a 3-point. I'll drag it to the middle, snap it to the middle like this. Snap it to this middle point. And then do a vertical, something like this. So I created this rectangle, and I want to make this height maybe about 30 or 20. Alright, so this will be the notch that eventually your boolean difference out. So what I'll do is as a small little detail, I'll fillet this corner as well. So I'll do a fillet. Do the sorry, it's now a bit off, so I'll just move it out first. Doesn't matter. Fillet it by 5. Then grab the top edge and bottom edge. Get this nice little fillet. Then I'll bring it back to this corner, and I'll extrude it. So I'll extrude it by a distance of 100, 150 maybe. And then I'll centralize it to the center of the drawer. So I'll take it from the middle, I'll drag it to the middle of the drawer. So now I have something like this. And oh right, shit, it's not a closed poly surface. So I realized my mistake. I think what I have to do is redo my entire thing. Sorry, so I'll actually have to redo the entire thing. So let me just quickly redo the entire thing. So I want boolean difference first. Previously I boolean difference, right? I'll boolean difference the nice rectangle here first, rather than boolean unioning it straight. So I'll do this. I'll shell this part so it creates the opening, and then only after that then I'll boolean union these two. So I'll boolean union these two like this. Yeah. So now this entire thing is a nice closed poly surface. Right, so now I have a nice closed poly surface, right? So when I finally boolean difference out the notch, it should work. So when I do a BD and I take away this handle, you can see that it creates a nice little notch now. So if I show it in a rendered view, it's kind of a bit nicer. So maybe if you push this out by 5 mm, you can even reveal a nice shadow gap over here, which you may want. So you've done one. Now you can just copy this nice drawer that you already draw, and you can move it up by 250, and to create that nice shadow gap you move it up a further 5 mm, so you can create this little shadow gap, and the shadow gap is more prominent in your rendered view that you can see these nice little dark shadows because there's a gap in between. Okay, so I have these two drawers done. Now what I need to do is I need to move this surface up. Remember the surface that I created for that platform? Need to move it up to this level, and then I need to create some thickness for this as well. So let's just extrude it. Extrude surface. Extrude it by the same thickness as the cupboard thickness, which is about 20. Alright. Okay, so I've managed to get the drawer so far, the platform, and as well as the internal space. So for the internal space, I'll need to put clothes in, I'll need to put a pole in, and I need to close it up with the doors. So let's just finish up with the doors first. For the doors, let's just draw a rectangle from the top now instead. I'll do a rectangle from the top to the middle, and then for the thickness, I will do a scale 1D to make sure the thickness is the same as the drawer below. So I'll do this thickness like this, and then I will extrude this curve downwards. And you can see that the distance is 1475 to hit to the drawer, but I want to create a shadow gap of 5 mm. So instead of using 1475, I will use 1470 to create the shadow gap. So now I create this door, right, that has that nice shadow gap below. And then I'll also scale 1D to create that shadow gap at the side. So I'll do this scale 1D to have that little gap, something like this. And then last but not least, what you want to do is to maybe grab this profile. I can do a dupe face border, and then I will orient this notch to this face here. So to do that, I can simply do a orient 3 point. I'll grab this and think of this as the first axis and the second axis like this. Then I'll push it over here by moving it down on this axis and then perpendicular on this axis. You can see that I've oriented that curve to one over here. And you may notice that it's the wrong direction, so no worries, just need to mirror it. So once you mirror it, right, now it creates that profile that you can finally Boolean difference. So with this, let's put it to the correct height first. Let's just extrude it by 150 as well. And here you roughly see what's the height that is correct. So for this, I'll agak-agak. I'll move this down a bit. It should not be in the middle, but slightly below. And then last but not least, you just Boolean difference away. So I'll take the door, BD. Then I'll Boolean difference away this notch over here. You can see I've created that inward portion. And last but not least, just mirror it. Okay, so I've created these two. And then last but not least, let's just do a bit of shadow gap. So I'll grab this entire, I'll make sure I'll do a solid point on, select all these solid points and move them a distance away. So I want a 5mm gap, right? So I need to move this by 2.5 and I'll move the other one by 2.5 as well. So I'll grab all the solid points on this side and I'll move it by 2.5 to the right. Okay. So that means now when you look at your rendered view, you have the two drawers and you have the two doors as well. Okay, so for this purpose, let's just open up the cupboard doors. Open up the cupboard doors, and for this, let's just pull open one drawer just to show stuff inside later on. Okay. So this just shows the open position of the cupboards. That's everything I did. And then now the next portion is a bit of furniture modeling and the bar as well. So for the bar, it's quite simple. I'll use this command called pipe to make a line into a rounded pipe. So the command is called pipe. The first thing I need to do is to just draw a line first. So I'll draw a line from the inner wall here to the other wall, and I can use the perpendicular function to make sure it snaps like this. Then I'll push it to the near the ceiling of the cupboard, something like this. And then I'll just type in the command pipe and indicate the radius of the pipe. So for those cloth hanger, right, you can see that they're very thin usually. It's about 5mm radius lah. So I'll just put a 5mm radius. You can see that I created a pipe, something like this. Maybe it's not 5mm, I'll do 10mm instead. Pipe 10. Okay, so I've created that pipe over here, and then I can just move it to somewhere in the middle of the cupboard. And this is the pipe that I'm going to use to hang all my clothes. You can do some further details, like the pipe usually has a nice kind of a screw-on cap in the side as well, so you may want to model that out as well. So for now, this is what I modeled. And then for most of your doors, right, for most of your clothes, right, for your clothes, you can actually keep it as simple surfaces with the crucial lines to show that it's a clothes. And then you just trim out the outlines, so you have a bunch of these clothes. And then you also have the hangers. So for all the hangers, you can see that there's a bit of a pipe that's applied to them. So you start off with the curves first, and then you add a pipe. So once you have this, right, let's just take one of these dresses that's already been modeled out. And in this case, we are going to do something very brute force lah. We're just going to move it. We won't use orange 3-point. I'm just going to move it. So I'll create a copy by holding alternate and holding the window over here, bring it somewhere here. So I have one dress that's still planar in this way. I'll make use of this gumball over here. So I will want to first rotate it 90 degrees on the planar plane. So I'll drag this. I won't drag it. I'll just click on this arc over here, the blue one, because the blue one is the direction I want to turn it. And then I'll input the degree. So I'll put in 90, and you can see that it's rotated 90 degrees now. And then now I want it to be rotated from horizontal to vertical. So you can see that this red arc is the one that is the correct direction for rotation. So I will click on this red arc, and then you can see that the arrows are going clockwise. So I want it to go 90 degrees clockwise. And when I click 90 again, you can see that now finally is this direction. It's a different one. I'll bring it to here instead. Okay, so you can see the direction is still wrong. The hangers are not supposed to be this direction, it's supposed to be 90 degrees as well. So I'll do a final transformation, final rotation of the green arc over here. I'll move this by 90 degrees as well, but this time instead of clockwise, I'm going anti-clockwise. I'll go 90 degrees, negative 90 degrees, and I'll just use the arrows here to just roughly move it to the pipe. So I'll just move it until it nicely aligns with the pipe. That is the bar over there. So just keep moving it until it reaches the pipe. So does this work? Still doesn't work. A bit more. Okay, so you've done like roughly one hanger already. Then you can really just use the arrows and alternate to create multiple copies. So you may want to start off with multiple kind of dresses, and then if you have other shirts as well, just put them randomly in the cupboard itself. And then to make it a bit more realistic, they're not all parallel, so you should try to rotate a bit here and there to create multiple copies of the same thing, but make it look more randomized in this way. So I'll just create all these copies, and then you can also try to change the scale to make some of them have different scales. So I'll maybe change this to a 0.8 scale so they all have different lengths and stuff. Okay, so this is roughly what I want lah. Then the more clothes you put in, the more realistic it gets, I guess. So this is for all the hanging clothes. This is what you probably need. And then the last part would be the clothes over here. So for this clothes over here, I'll go through that later. Now let's just do the bed frame. The bed frame is pretty simple. I'll start off with the wooden frame for all the beds. So it starts off with the wooden frame, right? What I need to do is to do a curve first, and I'll extrude the curve. So I'll do this curve something like this. And I'll extrude this by a certain height. So this height will be 400 perhaps. And then you know that this part is actually hollow. So what I want to do is I will do a Boolean difference. I will grab this face over here, and I will sort of change the control points. I'll offset it. So I'll offset it by maybe 30. And then for this, I will scale it such that it snaps to the bottom of the frame instead. So I'll extrude this entire thing, extract this entire piece. And now with this original frame, right, what I can do is I can Boolean difference. So now it creates that frame that has this open space at the bottom. And then I guess you can do some minor adjustments such that you can thicken this part as well. So maybe for this you want to lower the control points a bit, or lower these control points, or drag it down by a certain width, maybe minus 30, a bit more. And then I can do a offset of the top frame by 30, and I can push it down by maybe this, so I can create a cave-in portion. So you can see here, right, this frame is now more defined. There is an outer wooden frame, and there's this inset where you put your mattress. So this is probably the kind of details you want to look at for your bed frame. And then the next will be your mattress. So let's just do a simple mattress, grabbing the lines again. So I will just move this out of the frame for now. And then I will trace the mattress shape. So in this case, I will take this rectangle. I'll just try to get a rough rectangle like this. And then slowly scale it such that it matches my drawing. So once it matches my drawing, then I can move it up. I'll do a move, press N, and then I'll select the vertical over here. So I'll move it up from the where a point on the curve vertically to snap it to this height, which is the bottom of this frame over here. Okay, so I've done that, right? Then let's bring back the frame. So I'll just move this frame back in. So now you can see that I've got the frame and I've got the line, I've got a curve for my mattress. So for a mattress also, it doesn't have this like sharp edges, right? But it doesn't matter, we can do fillet edge later. Let's just extrude it first. We extrude the mattress by the thickness, so you need to measure the thickness of the mattress as well, which in the top of my head is roughly 150 or 200 maybe. So I create a mattress of 200 thickness, and then in order to create the rounded edges, I will do FE, so fillet edge. So fillet edge, first of all, you need to note what's the radius that you want. So in this case, I'll have a radius of 5 cm, so I'll do 50. I'll grab this edge, the edge at the back. Doesn't work. The edge at the Okay, I'll just change to ghosted view so I can see which edges I'm looking at. So I'll do this one and I'll do this one as well. Then I'll go back to my shaded view. So I've grabbed the 4 edges of the poly surface and I made it I'm gonna fillet these 4 edges. So when I finally do the operation, right, you can see that now it's gonna round these edges. So when I press enter, it's now created this this nice detail. So I guess for most of the bits, it's not just filleting this edge, right? It's also filleting these edges as well. So I can do that second step. I'll fillet edge again. I'll grab all the top edges. Wait, select the radius first. So I need the radius to be about 5. Select all the top radiuses. You can see that it's selecting all the top radiuses, and then you do the same for the bottom. Actually, this step is not necessary. You can not do the fillet edge, because what happens when you do a fillet edge is you lose the edge, you lose the edges. So when you finally make 2D, right, the edges will be gone, which is bad lah. So sometimes you may not want to do that. I'm just gonna do what I feel for the model is nicer first. So once I have all these edges selected, okay, let's do that fillet edge. So now you can see that this portion is rounded off as well. So now I got a bit like this, and next step will be to do the blanket and the pillow. So for the blanket, right, how I do it is I will first trace a section curve of the rough outline of the blanket, and then I'll extrude it and I will use cage edit to really deform it to make it look more organic. So let me demonstrate it. First step is to create that section curve. What I need to do is to create the rectangle first. I will take this rectangle and I will bring it back to the bounds of the entire bed, and I'll do a inter curve over here. So I'll do this interpolate curve, and I will try to create kind of like a, sorry, let me do a C-plane change first. So I'll do this C-plane change, and this will help me drawing my curve projected. So I'll do curve something like this. It goes out. For all blankets, usually they go out a bit, right? So it's good to have it go out a bit and comes back in. Then you can start to, I guess, model it like in this manner where it has a bit of folds and stuff. So again, I'll just complete the entire section like this. Okay, so I have a curve that's something like this, which will help me to extrude it later onwards. So you should know that none of this should intersect with the bed lah. So if you see any portions that's intersecting with the bed, what you should do is to grab the control points first and move it such that it's not intersecting with the bed. So I'll just make sure that all these are enabled first. Same for this side, maybe I want to push it out a bit more, and this side I push it out a bit more. Alright, so now I have this section curve for the edge of the blanket. Now I'll go back to my original C plane and I'll extrude this curve to somewhere more than the halfway point. So I'll go, let me just do a new layer. Okay, so I'll do it somewhere here for the blanket. You can see that currently it still looks very rigid, right? So this is currently not that nice yet. So here is where the magic of cage edit works, where you need to use cage edit. Okay, so let me just move it out a bit more on this side as well. So when I push it out a bit more, right, now you see what I'll do. I'll do a cage edit, and this is another function of Rhino where what you do is it creates a cage of the object, and it creates a lot of these control points along the cage where you can start to move the control points and deform the object. So that's the whole point of the cage edit. So when I have cage edit selected, what I want to do is select a control object, which will be the bounding box over here. Your coordinate system, you keep it as the world as well. For your X and your Y points, you want to change it to a big enough number, which is, I think for this size you probably want something like 6, maybe 6 X points, 6 Y points, and your Z points you don't need that many, so you change to 2. And then for your X degree, it's good that it's at degree 3, so you're like your NURBS curve, your degrees should be roughly 3 to make it a nice curvature. So once all these parameters are set nicely, press OK, set to global, and then you can see that now you generated a cage like this. Oh, okay. Actually, you know what? For the Z parameters, I don't want to keep it as just 2. I want to increase it. So let's just do the thing again. I'll select everything again, but instead of my Z point count as 2, I'll keep it as 6. I will want it to have 6. And the Z degree, I want it to be as 3 as well. So you can see that I'm creating more control points on the Z axis. So the first step is to mimic that kind of like blanket folding down moment, right? So in this case, you don't want the blanket to just be straight extruded. So the way I can do this is I grab the control points at the end and I'll scale 1D. So I'm going to squash this final point to make this thing look like it's bending downwards. So I'll grab the bottom, the top, then I'll squash it. You can see that there's some deformation that's happening. And then for this portion, since this part is squashed, right, to compensate this portion, you may need to scale 1D upwards instead. So if I scale 1D this upwards, and if I move this a bit outwards, and I move everything inwards a bit, can roughly mimic that kind of like folded bed sheet look. So just keep moving the control points until it suits how you want it to be. Okay, then now in addition to the blanket, right, we need a bunch of like folds. So to create that folds is about changing it's about manipulating all these control points such that you can create maybe a fold here and then a fold there. So probably this cage doesn't work because we need greater increments of the cage. So I'm done with this cage, right? I'll just delete first the original cage, and then I'll do the cage edit again. So I'll type in cage edit again, go bounding box, go world, and increase the X point count from 12 to much higher. So I'll go from 6 to 12 instead. So something like this, create more control points. Then I can start to twin each point more such that I create more localized folds. So maybe this portion I can push it up a bit, not too much, just a bit, just to create the folds. And the most important thing, right, is when you're capturing the isometric view, you are basically you want to take note of the edge of the blanket. That's the most important, to kind of like mimic that kind of organic flow. So in this case, you don't want the edge to be purely kind of flat like this. So it's important for you, when you do all these control points, to sculpt how you want the edge to be. So in this case, I'm going to grab a few of these edges like this and move them up, so I can kind of change the edge of the blanket a bit, so it becomes a bit more becomes a bit more less flat, becomes more like more curvaceous in this case. So in addition to just the vertical direction, right, also for the sides, usually it's not so flat lah. So it's good that we can manipulate some of these control points, just push them out a bit to create the folds on the left hand side as well as the right hand side. Just push a bit of these control points out. And then same for the corner, maybe you want to drag the corner a bit. So roughly you get a nicer curvature of your blanket. And if you look at my subsequent blanket in the file as well, right, I not only did one surface, but I did two surfaces. So this represents like the fold up moment of the blanket. So when you finally look at the rendered view, right, if you only have that single surface, the top part doesn't look very believable, because usually it's not like one single cut like this. You usually have a fold in. So you need to create a separate surface at the top, and you cage edit that as well to create multiple folds. So what you have is one surface on the bottom like this, and then another surface that you cage edit on the top to create the folds. So now you can see that this blanket looks slightly more realistic, right? So if I bring this back to my bed, right, so I'll just put it back here. Delete this cage. Even having this additional layer helps to define the blanket slightly more. Yep, so all these techniques are for you to kind of like model the more organic parts of your bed. But if you realize that you want to give up and just trace it out in your 2D drawing, you can also do that. So it's up to you. Then the last part would be the below. So when does the lesson end? 12:30. Oh shit. Okay, so I think right after this, right, I will need to move on to how to extract the side model and the block already, because we only have 15 minutes left. So for the rest, I guess it's the same operation. Just figure out what's the Boolean operation that you need, and then for curved objects, figure out whether a loft suits better, a sweep works, or you need to do a patch. So I've taught the techniques today, and then for each object you need to discern by yourself which is the technique that you will use. Okay, so I've done for the cupboard and I've done for the bed. For the pillow, okay, I won't do it anymore, but best is for you to use a loft or something like that. Create a few sections and then loft it. Alright. Okay, let's go on to extracting your site. So for this, this part everyone can do it together now. Let's go to a website called catmapper.com. So if you have your laptop with you, you'll be extracting your block right now. So go to catmapper.com and click on Get Started Creating a File. Okay, so the good thing about Singapore is almost every part of Singapore is already mapped on OpenStreetMap. So it contains both your block heights, all the park zonings, the roads, everything is contained within the OpenStreetMap. So Cat Mapper just takes the OpenStreetMap data and converts it into a Rhino file that you can use straight away. So in this case, for the options, right, you notice that the free file only allows you up to 1 kilometer square. So the moment you zoom out even more, you have to purchase a file. So for most of us, we don't need that. We can just keep it at 1 km square. So I'll just bring the boundaries down such that it maximizes that 1 km square. And then here you can type in your address. So what if you stay in Marina Bay Sands? You can also do that. I will take this Marina Bay Sands, shrink it down to about 1 km square, and make sure on the left hand side you keep your design program as Rhino. And for these 3D buildings, this is where you want to enable the 3D buildings, because OpenStreetMap has all the 3D building data, but usually what they don't have is terrace houses. So if you stay in a bungalow or terrace houses, right, they will not map those. They will usually map the HDBs, because HDBs are usually government owned. So in this case, what you can do is you can apply an arbitrary unit for all those houses that do not have a height data to them. So I will set all the false height data, all the false heights that you see here that do not have a height data, as my bungalow or terrace heights. So I will think of it as all the terrace heights usually is about 16 meters or 15 meters. And that's why I put the value here as 15-16 meters. So it helps to fill up all those buildings that do not have a height value as a default value of 16. So all your HDBs have nice heights to them, then all those terraces that do not have heights to them, I put them as 15. And then topography, usually I think for most of you, unless you stay in a mountain or a hill, right, you will not use the topography command. So let's say for Marina Bay Sands, for SUTD, I don't think you need the topography. So unless you stay in like River Valley or some like red hill with a big hill, then your drawing will definitely need that topography with it. So I think for flat ground, I will not use topography. I'll just turn it off in this case. And then last but not least, you want your road geometry. So your road geometry, I will not use center lines, because center lines usually have you cannot make them into surfaces. They are usually just a line that denote the center of the road. So I will use outlines instead, because outlines you can make them into surfaces. They have the left outline of the road and the right outline of the road. These are usually offsetted from the center lines. So here is where you demarcate what the thickness of each road is. For highways, I put it as 12 meters. For major roads, I put it as 8 meters. Minor roads, I put as 5. And then for walking paths, I put them as 3 meters. So I think these are values that are just sufficient enough for you to generate a model. Okay, maybe let's not use Garden by the Bay because there's not much residential. Let's just use Amokyo or something. Grab one of those HDBs. Right, so I want something like this. Amokyo, I will just, for now I won't think of it as a sloped land, so I'll just turn off the topography. So in this case, this is enough. Make sure Rhino 5, then I'll start to create the file. Okay, as you can see that all the data of the HDB blocks are captured. The parts are shown as green, and you have all the roads as well in nice surfaces as shown. And there's even an MRT station right there. So this file is good for you. You can just download it. Download it as here. So if you are doing it concurrently, you can also download it so that in future you don't have to do this step anymore. So with this, I'll unzip the file. And unzip it. Okay, this is the unzip file. And let's open the Rhino model. So this will be kind of like the output of what CAD Mapper gives you. It contains all the outlines of the roads, the buildings with the surfaces, and if you go to your layers, right, you have parks as well. So if you go to the parks, you select objects and you hatch this, right, yeah, this will help you to identify which are the parks zones. So if you have a master plan scale, you can just quickly select the layers and hatch them to know where's the parks and stuff. Okay, so let's say you identify one of the blocks as your HDB. Which one is a nice block to identify? Let's pick one of these blocks over here. Okay, a block like this, right? Then what you can do is, while all the other blocks stay as messing blocks, you may want to apply more detail to your actual block that you're defining. So if you look at some of the old examples of all the Excel drawings, right, you can see that for most of them, let's see if I can find a HDB.